Hello friends, welcome to Power Electronics. We have discussed in the previous class the voltage commutated chopper, in which we have studied the graph and also we have seen the various modes of operation, that are mode 1, mode 2, mode 3 and mode 4, in which the how first mode it has two paths, then how the thyristor T1 gets commutated. So these all the steps we have seen in the previous class. Today we will discuss the disadvantages of the voltage commutated chopper. So first of one of the disadvantage of the voltage commutated chopper is that a starting circuitry is required. So that we initially require a capacitor that should be charged by the switch or by the triggering the auxiliary thyristor. So we need a starting circuitry is required. Second thing is the load voltage at once rises to 2 Vs at the instant of commutation of main SCR is initiated. So freewheeling diode is subjected to twice the supply voltage. As you have seen in the previous class also, I have discussed that this 2 Vs is very dangerous. This is the damage of the diode. So we have to be careful with that. Third point is that it can't work at no load. So at no load it do not work. Why? The reason here is that capacitor would not get charged from minus Vs to plus Vs, as auxiliary SCR is triggered for commutating the main SCR. So if we have seen the circuit here in the previous class, that for this path to conduct, for example, there are two methods of conduction. One is that when we close the switch, current flows through the capacitor, then through the resistor and then through the back path. Another method is that current flows through this path and then through the capacitor, then we have to trigger the auxiliary thyristor, then it flows through the load and then to the back path. So there are two methods of triggering at the start, so that it do not works on the no load. Because why? Capacitor would not get charged from minus Vs to plus Vs. That is why auxiliary SCR is triggered for commutating the main circuit. So these are the disadvantages. Let us discuss the numerical on this. So if you look at here, a voltage commutated chopper feeds power to a powered electric car. The battery voltage is 60 volt. The starting current is 60 amperes and the thyristor turn off time, that is TC, is equal to 20 microsecond. So calculating the values for the commutating capacitor and commutating inductor. So if you look at the formula of the capacitor is that's TQ, that is called as circuit turn off time, plus delta T safety margin. So I naught is the load current along with the supply voltage. So we will put the value in this. We know that what is the value of the circuit turn off time, that is 20 microsecond, plus we have taken the safety margin, that is 20. So it is 40 microsecond. So this is the 40 microsecond into the load current, that is 60 amperes, upon the supply voltage, that is 60 volts. So you will get the value of capacitor equal to 40 microfarad. So here we have to calculate the value of commutating capacitor. So in case of inductor, L is greater than source voltage upon the load current square into the capacitor. So we know the voltage is 60 and load current is 60 ampere. So square it and multiply with the capacitor. We have already calculated the value of capacitor. Put in this formula, you will get the value of inductor. Also you can see here the L should be greater than or equal to Vs square into C. So this is the way how we can calculate the numerical. Thank you very much.